Welcome to Pure Mathematics 1, Chapter 8, Vectors. Topic: the angle between two vectors. When we have two vectors, which is one like this and maybe one like this, we want to find the angle between these two vectors. And how we can find the angle? We use the formulas that we have here. We have a cos of theta equal to A multiplied by B over modulus of A multiplied by modulus of B. Into the this one is called the scalar product. Or in two dimension, if A, vector A is vector A and vector B is given by the term A1 I plus A2 j, and B is given in the form of B1 I and plus B2 j. So the scalar product of A multiplied B will be equal to A1 multiplied by B1 plus A2 multiplied by B2. If I have an example here, if I have A equal to 2I plus 4j, and B, which is equal to 5I minus 3j. So my scalar product, which is A multiplied by B, would be 2 multiplied by 5 would be 10 minus 4 multiplied by minus 3, which is equal to 10 plus 12 equal to 22. That's how we can find the scalar product for two dimension. And here you see A multiplied by B. What are they? As I told you before, when you have the modulus in here, it means the length of the vectors. So the length of vector A would be equal to, A1 squared plus A2 squared multiplied by the square root of B1 squared plus B2 squared. In this case, it would be square root of 2 squared plus 4 squared multiplied by square root of 5 squared plus minus 3 squared, which is equal to square root of 20 multiplied by square root of 34, which is equal to 2 multiplied by square root of 170. In this case, in order to find the theta, we have cos theta equal to 22 over square root of 2 multiplied by square root of 170, which is equal to 0.843. So we want to find theta equal to cos 1 of this one, 0.843. I think that when you get into this step, you should not round up. Theta equal to 32.5, rounded up to 3 significant figure. We use the same formula to calculate the angle between two vectors in 3 dimensions. We use the vector cos theta equals A multiplied by B over modulus of A multiplied by modulus of B. In 3 dimensions, vector A will be in the form of A1 I plus A2 j plus A3 k, and vector B will be in the form of B1 I plus B2 j plus B3 k. And now AB is our scalar product. Only AB, not this part. Only AB scalar. A multiplied by B is our scalar product. So in this case, A multiplied by B will be equal to A1 multiplied by B1 plus A2 multiplied by B2 plus A3 multiplied by B3. And for the values of this one, modulus of A multiplied by modulus of B equal to square root of A1 square plus A2 square plus A3 square multiplied by square root of B1 square plus B2 square plus B3 square. Just substitute the numbers in and we can find the angle between two vectors in 3 dimensions. And now we will talk about perpendicular vector. Perpendicular vectors. So for perpendicular vectors, mean that when two vectors they cut each other, they form an angle which is 90 degrees. So the theta will be equal to 90 degrees. So in this case, you have cos of theta. Cos of theta will be the cos of 90 degrees. Will be equal to 0. And you know that the cos of theta equal to A multiplied by B over modulus of A multiplied by modulus of B. So this one will be equal to 0. So it means that A multiplied by B equal to 0. So the scalar product equal to 0. So in order for two vectors are perpendicular with each other, their scalar product must be equal to 0. That's how we can prove. I have two vectors. This one, 12 and minus 2. And this one, 4 and 24. So let's see whether these two are perpendicular or not. We have A multiplied by B equal to 12 multiplied by 4 plus with minus 2 multiplied by 24 equal to 48 minus 48 equal to 0. So these two vectors are perpendicular. And I have another example. I have this one, the vector 7 and 2 and vector 13 and 3. So A multiplied by B equal to 7 multiplied by 13 plus with 2 multiplied by 3, which is 97, different from 0. So this one, these two vectors are not perpendicular. Here are some notice for you guys. We have cos of theta equal to A multiplied by B over A B like this. In a question, if they want you to find the angle PQR, this angle you have PQR, PQ and R. When you use this formula, you have cos of PQR equal to QP multiplied by QR over this modulus of QP multiplied by modulus of QR. Please notice that if you want to find this angle, please use the one in the middle, the Q, to be the starting point for vectors. In this case, PQR will be PQ and PR. If you have M and C, this angle, you will use the vectors of M and vector and C in order to calculate this one. Remember that, don't use something like PQ multiplied by QR, or QP multiplied by RQ. Because when you use the combination, the values that you calculated will be wrong, and it means that your answer is wrong, sir.